Okay, okay, okay. Okay. Today we will start with the topic IoT privacy and security. Okay. Now and vulnerability solutions. How actually IoT. Okay. Uh, like what is the meaning of trust? Okay. Then why the importance of security? Okay. Then privacy. Why privacy is required? So all these things we will be studying in this topic. Now, actually, while getting into the thing, we need to know few terms. Uh, Trust. Actually, what is trust? It is that is actually very important. It considers the message and video clips of the operation, uh, like from one server. Okay, and it when it delivers to the other place. So, like it has to be um, like the address has to be authenticated. The sender or the transmitter which transmits the data, which should have the trust that the data whatever I'm sending is fully secured. Okay, so it is assurance what you give, assurance that the received information will not be disclosed, okay, which can harm the sender or even the transmitter. Okay, so that is the trust. To build up this trust, so we need to develop certain algorithms. Assurance of safe use of existing data. Okay, when uh, devices or systems or computing nodes they communicate. Okay, so that assurance should be given. So that is called as the trust. So for that, actually, we need to go for the privacy and security. We need to give importance for that. And what is security? Security refers to securing data while communicating from one to another, and data unaltered or does not reach to hands of unrelated entities. Okay, so that is you are ensuring that the data whatever you have sent is going to the right system. Okay, right person, the right receiver. So that is the security. Next, communicated data remains known between only two entities in the secured data communication. For example, when the video clips, okay, communicate on internet in a smart home security application, privacy refers to protection of the clips, okay, from reaching to unrelated entities that can lead to serious breach of home security. See, now actually, home security is made for the ease of day to day life. So, in that case, the video clips or any information what has to, like what you communicate to the systems which are at home, if that is actually hacked, then actually the entire system, okay, will collapse. So the idea of having the a smart home will not be successful if the security is not given properly to the data transmission. So for that purpose, actually, we need to have security. Okay. Then another term, what is like hash? It is refers to a collection or bundle of operations. Okay, a bundle of operations which gives an irreversible result. So once you have done, yeah, it is done. Like you usually if you like when the mail id or your password or whatever it is sent, before sending that, okay, this hash algorithm runs. Okay, this hash algorithm, that's why it is set of operations. Okay, it generates, I mean, 128 or 256 bits message. Okay, now that is the security code. After this hash operation only, your datas are sent. Okay, after many operations on that, and operations are just one way. Okay, operation. So from wherever actually we are starting our communication, from there actually hash algorithm is uh, there. In that place, hash algorithm will run, and uh, the after that, okay, the code is generated. After that, our data is sent, okay, which is assumed to be safe, okay, and secure, and it reaches the destination. After that, again from there to decode, no, that it is irreversible process. Okay, hash algorithm refers to a set of standard operations, okay, using an algorithm called secure hash algorithm. Okay, the algorithm refers to a generator of fixed size, as I said, 128 or 256 bit value. That is, we'll call it as a secret key. Okay, now why hash? Hash is for authentication. When data such as ID, password, okay, needs secret communication for the purpose of authentication, then it is communicated. Okay, after applying a hash algorithm, only the hash value communicates. Okay. Receiver end retrieves the hash value and compares that with the stored hash value. Okay, if both are equal, then the sender message is authenticated. Okay, so this is actually the use of the hash. Okay, next actually this you are you very well know this. Okay, encryption. The process of generating new data using a secret key is known that secret key is known only to the receiver. That process is called as encryption. So before sending the encrypted data, okay, sender and receiver both identify each other and both know the key that will be used by them. The encryption using 128, 192 or 256 bit key for encrypting the data. Now actually this is a very standard one. Now you know that actually different type of encryption and later decryption can take place. Okay, next one more thing is use case. Now this actually now we are just studying the um, terms. Okay, in detail about this we will be studying later. Now what is use case? It means a list of event steps or actions which define the interactions between two ends. Okay, in which one is playing the role of the server and the other as the system. Okay, the steps accomplish a task or goal. Okay, now the one end, okay, is called as the actor, okay, in unified modeling language, while the other end is called as the system. Now the use case is a software engineering term. Okay, now similarly we have misuse case. Okay, misuse case, this refers to a reverse sense of use case. Now it defines the behavior which is not required from the software under development. uh, okay, it defines the behavior which should not happen, also specifies the threats. Now all these use case and misuse case comes while studying the threats. Now actually these are the like you can think as a windows which pop out. Maybe like any threats are there. Some are the defined threats, some may be undefined threats. Okay, so when these threats come, like will
Excuse me, ma'am.
yeah,
Yeah, you have not started the streaming, ma'am. Like there are a few people who are waiting for it.
I have started the streaming. No,
No, ma'am, it's not streaming.
correct now. I think they can get it now. Yeah, now actually, can you see the PPT?
Yes, ma'am.
Okay, okay, okay. Let them join now then. How many are there? Only 100 could join. Yeah. Let us wait for 1 minute, okay? Why others are not joining? Just others message them. 121 are there, right? Message them, no? Vijina, are you online?
Yes, ma'am.
Can you message that streaming is started? They can join. Only one person has joined.
Oh, just a minute, ma'am. I'll just inform on the class also.
No, they haven't joined. Okay.
Ma'am, you can just continue, ma'am. Maybe someone would join later.
Yeah, yeah, yeah. Fine. Okay. Now we were discussing about use case and misuse case. Now, actually, these are the like indications. Later, we will be studying in detail indications like when the threat comes. Okay, for any application while running. Okay, there are many defined threats as well as undefined threats. So when these threats pop up, okay, misuse case also start running. Okay, misuse case. Now this refers actually whether this will have the steps or the procedures to tell whether this is a required behavior or okay, non-required behavior. Okay, then the user okay, has to decide whether it has to be discarded, or so then depending on that the misuse case will run the uh, program, and it will discard the threat. Okay, so that is why these two terms are there. Okay, use case and misuse case. Okay, next, what are layers? This is very simple. It's a stage during a set of actions at which the action is taken as per the specific protocol. So the result passes either to the upper layer or to the lower layer until the set of actions complete. Okay, so this is same layer is like how we have studied in any other protocol or any this thing in the networking. Same term is used here. Next, what is firewall? Okay, firewall refers to software interface. Okay, that interconnecting networks with differing trusts. Okay, so the like what is trust, that is defined for each software, each platform. So if when two two software are interconnected with differing trust, then actually their firewall comes, because their interests are different. For something, for one of the platform, okay, so, uh, some data is like it has to be secured, okay, or privacy is required. For the other platform it is not so much, so there the trust differs. So what to send, what not to send is decided by the firewall in these cases. Okay. And is immune to penetration, providing perimeter defense. So there will be like understanding between the two software interfaces, okay, like what to share, what not to share, because their trust is differing. So that work is done by the firewall, functioning as a choke point of controlling and monitoring. Okay, it does auditing, and it provides controlled accesses. Okay, controlled accesses, see, check here. So allowing only authorized traffic, okay, imposing restrictions on the network services. So this all depends, okay, which type of software interface you are doing, raising alarms on abnormal behaviors. So that is the function of the firewall. Next, message privacy. Message is not reaching into hands of the unrelated entities, okay, should not. So the privacy is required when data or messages communicate from the things, okay, those are only for the applications and services and for targeted goal only. When you are sending the data or message, then actually message privacy is required. Privacy also means no interference or disturbance from others. Okay. Now, need for privacy. uh, Now actually see, this is one of the possible questions in this unit. Okay, all three: uh, privacy, security, okay, and trust, privacy, and security. Right? Okay, the need of it, advantages of it, or functions of it. Okay, for 10 mark, if you are going to get it, then all. Okay, function, advantage, and need. Okay, consider an example of messages from the embedded devices in an automobile using internet. Okay, that is smart car to an automobile service center. Privacy means the messages reach only the center. Okay, that particular center, and used by only the services of the center. So and like what they mean is, another automobile company, if actually it is able to hack this, okay, the data from the smart car, then actually the other company is able to get the datas or the functionalities. Okay, what are the functions of that automobile company? Okay, what are the functions of that automobile company, or what are the datas? Okay, so it can be hacked. See, every time every data is not required by everyone. What I mean to say is, now if I get a like if I am able to hack a like data from the smart car, then it is of no use for me. Okay, then it is of no use for me. But in case another automobile company hacks it, then it is of the greatest use for it. So actually we need to go for the privacy of the data which is transferred. Okay, so privacy policies, it needs to determine that how much of the IoT devices data, and which data need absolute privacy and which need limited privacy. Okay, so that is a privacy policy. Now that is what privacy policy differs means, that is a trust differs. Okay, if the trust differs, then actually while communicating, firm where comes into picture. So this privacy policy is not common for all. So basic, very basic standard rules are there. International standard rules are there for the privacy policy. But again, from company to company, okay, they have changed their privacy policies. Okay. Now, vulnerabilities of IoT. It means weak without complete protection, subject to attack. Okay, it is vulnerable, it is subject to attack. So IoT vulnerabilities due to participation of the number of layers, okay, hardware sublayer and software in applications and services. Because if you see, the eavesdropper can hack in different layers. Okay, they can hack in the different layers, because when the encryption is done, we have seen in the different layers, different type of encryption can be done. So if any one of the uh, idea is known, then actually it can be in the sub layers it can be hacked. In the IoT world, sensors, machines, automobiles, okay, wearables, and each faces different kind of vulnerabilities and has complex security and privacy issues. Okay, so it is different kind of like privacy issues are there. So security has to be provided depending on which type of data you are dealing with. Okay, eavesdropper creates security issues. Like an eavesdropper, say E, listens to the messages and commands in the network during communication and obtains confidential messages. This is the one actually which is most this type of uh, security issue is the one which you tend to get most of the time. Okay, so like banks, mostly when actually money transfer is involved, you get this type of this thing. So they create their own sub platform, okay, which is a replica of the existing one. And when they ask the customer, okay, or the user, the all the details, okay, all the credentials, if okay unknowingly if it is given, then actually they can access all the data through through the data which you have given to them. So to avoid this, we need to have the uh, privacy. Okay, a server at E sends fake commands. That's what I said. This is the replica of the actual server. Fake commands, which the devices assume that data is from the device or application. A fake device at E can be used to send the device data, okay, such as sensor data, requests, and commands from E, or disrupting the control system. Use of secret key encryption can protect the messages to and from device, server, or application, okay, or a service. However, a device software generated string which can be cracked by trying large number of combination. Okay, so that is why again say security key will be there. You might have observed in many cases when you give your password, okay, three, if you miss it three times or five times, it will give the option to you, okay, to re-log in, to reuse your password. If you fail to do that and within those given try, then actually for that particular day or that particular whatever, okay, the duration, you cannot try again because you are considered as eavesdropper hacker. So because this is one of the use, large number of combinations, okay, are done to crack the security system. Next, open web application security project, OWASP. Now here actually in this the lot of what you call procedures are there for the open web application. Okay, it is open source and has a free to use licensing policy. Okay, a community model based software development initiative it is. It undertakes the associated security issues of IoT for the purpose of helping developers, manufacturers, and consumers. Like in the sense, if it is required, okay, then actually it undertakes associated security issues. Otherwise, it is an open source. Okay. See, these are the identified top 10 vulnerabilities. Okay, there is possible places or the areas where actually hacking can be done. So one is insecure web interface. Okay, the next one is insufficient authentication or authorization. Next one is insecure network services. Then lack of transport encryption, okay, or integrity verification, privacy concerns, then insecure cloud interface, insecure mobile interface, insufficient security configurability, insecure software or firmware, poor physical security. Okay, see, these are the possible. Okay, again, I repeat, at once you may not get this. Any one are the expected. Okay, apart from this, unexpected vulnerability also like exist. Okay, unexpected. These are the quite uh, like common one, like which you always face these problems. Now, security requirement, security functional group, okay, which is one of the architectural component which has 5 sets of functional components FC. Okay, so these are the components required FC ensuring security and privacy are identity management, okay, authentications, then authorization, then key exchange and management, trust and reputation. Okay, see, these are the 5 ensuring security steps, okay, which has to be taken. Now, group components, security function, group components of IoT, like what we have seen here. In the device, this thing, the side, it is, okay, tags, activation, sensing, storage, and data processing. Okay, in the device side. Then here actually in the actually middle system, okay, you have identity management, which like functional component these are identity management, then it has to give authentication, authorization, key exchange and management, trust and reputation. Okay, this is the like in the for the security purpose, the functional components, okay, done by the functional groups. Then application support layer, here it is. So applications and business applications. So from here actually it goes, these 5 operations are done, then it is sent to these places. Now here actually these things are there. So authentication also is sent by here, then again it is sent back, so it is bi-directional. Authorization also, so key exchange, all these things. Okay, then actually it is sent to the application support layer APIs. Now, next is threat analysis. Okay, see, the system has to do the threat analysis. Okay, the analysis has to be done. Then, actually, if it has to be attended, then it has to be attended then and there, or it has to be discarded, then it has to be discarded. So, further action has to be taken, or the security has to be changed. So, all those what you call decisions have to be taken. So first you should go for the threat analysis. Now threat analysis means uncovering the security design flaws after specifying the stride category. Okay, now stride means like it is passing over or across in one long step, in the sense like many operations you do and immediately like you come to in one particular jump, you come to the one result that way. So stride category, okay, continuously data flow diagram, elements between that the interactions occur during the stride processes which are activated for analysis. So this is actually thread analysis. So now you do the analysis uncovering the security design flaws, okay, for what and all data flow diagram elements, okay, between whatever interaction is taking place. So those elements are there, right? So the elements involved in the data transaction data transfer. So that security, like uncovering the security design, okay, this is a threat analysis you are doing. Okay, threat analysis, like you're just seeing whether it is right or no. Okay, now what is stride? Stride means a regular or steady course. okay, or a study or the pace in that one particular. So it is actually passing over or across in one long step. Many operations are done at once and one result is given out. Okay, set of statements when considering a threat to a software component. Okay, next, threat analysis tool. Okay, it first generates the threats and analyzes a system for threat. Okay, a model is designed for the threat analysis with definitions of the strides and elements first. Now, this is actually we are designing the tool for the known threats. The interacting elements are processes, data stored, flow. Okay, that is threads. Okay, there are boundary or maybe external specified elements in the system. It has three components. Okay, getting started guide. Now, actually, what has the tool analysis tool has three components. Getting started guide. Okay, then create a model, then open the model. Okay, just to check whether is that the threat. Now, this is actually creating the model just to check is that the known threat, because threat all of a sudden it comes. Now we need to analyze which type it is. So these are the three steps to analyze. See, create a model is after getting started guide. Okay, once the model is created, then open a model comes. Okay, which proceeds the threat analysis for the each stride. Tool also provisions for definitions of new threats, as I said. Okay, some of the like sudden occurring threats also it has to accommodate using a stride category. Okay, a stride category is first created. It generates a list of threats which are active based on interactions between the elements. The list is as per the definitions in the model open for analysis. In the sense, now it categorizes between the active and inactive threats. Now see, uh, what can I say? Threat can be suppose from a sensor you are now you are obtaining the data per year. For each minute you are obtaining the data of a temperature sensor from a temperature sensor. Now when that data is getting transferred, your system power is it is like consuming more amount of power in your system. Okay, you think that that is one of the feature. Okay, so now maybe after 5 minutes itself, okay, you the threat is your system's power is going below the threshold level. Okay, your threat, see, threat can need not be from the outside, like yours dropper only. Anything which is like harmful to the existing condition, we categorize it as a threat. Now in the temperature sensing application, when I was doing, I that is which one, power consumption, that is a power level checking, that becomes the active stride. Okay, active stride, because that is the one which you need to take care each and every time. Next this thing is I am communicating to some other person. It is not at all related to temperature, something else only I am communicating. Okay, but it comes under IoT, think like that. Okay, so now the power consumption is very very low, which I need not bother each and every moment of time. Okay, now that threat becomes inactive for that particular application. I hope that is clear. So depending on the application, threat becomes active or inactive. So now the analysis tool has to first categorize them for this particular application, which is the active threat and which is the inactive threat. Okay, so it has to concentrate on the active threat. Huh. Now this is the uh, thread. Okay, one this thing. So see here, this is the web service. Now here actually is the web context. One second. Now Now element types here are process or data store, flow, okay, boundary or external specified elements. Okay, now here also the tool predefines a number of threat categories. A new category also can be created which were not in the your list, that also can be created. A tool suggests threat definitions and generates, okay, the mitigation solution automatically. Once the active threats are identified, okay, it generates the mitigation solution automatically. Now the tool messages on display show the vulnerabilities and the data flow diagram. Okay, now see here the this thing between the device and the application or service. The analysis view, okay, shows the active and inactive threads. So now here actually when this connection is there, it the what is that, the threat can be, okay, common threat can be data store inaccessible, okay, or it can be denial of service category. Now here actually it is stored. Okay, from here it it reads and identifies the active threats. So the and it also generates the this thing to mitigate, generates the solution, okay, to mitigate that threat, and it keeps, because threat every time we need not run, only when it occurs, okay, active threat is kept in the alert system, alert mode, that's it. Okay, only when it comes appears, then it has to be, the program has to run to mitigate that. So in this in that way actually here from the store system it reads and it keeps the thing active. Then when it requests for the data, okay, from here the threat can be access denied. One of the this thing example. Okay, then actually see according to the trust, it has to share the data. Okay, but that now the threat is it is access denied. So again you can check, okay, you can keep the security system alert to just to check whether it is the same server which has sent the message, or it is from the fake server which is being sent. Okay, so whether this is actually the server, whether the whether the information or the what you call the message was sent from this server itself, or it was from any fake server, okay, from here. So that can be checked using the security uh, algorithms what we have. Okay, next is computational security tomography, identifying the network vulnerabilities used in computational security in complex set of networks, okay, needed for the design of efficient attack strategies. Okay, it means finding attack vulnerable sections or subsections. Okay, attack vulnerable sections, this is it will just identify, observe threats using a finite number of tools, okay, in a complex set of subsystem. Then network tomography is it refers to study of vulnerabilities and security aspects for network monitoring in a complex system. For wireless sensor networks, RFID networks, we have IoT networks. Okay, then allocating resources and ensuring the network reliability and security. Okay, here also we find that threat can occur. These three are the areas for the network. This also is possible. See, now these are the layers where actually you get, okay, these are vulnerable to the different type of threats. Okay, see these two, application service and application support. This I think you know by now. This layer is meant for the IoT. Okay, that is in the first class itself we have learned that was what you call mapped. Our OSI model was mapped to this layer, okay, model. This is for the IoT. So here actually first these two vulnerabilities in application or service can be exploited through attacks such as SQL injection, okay, where the developer has failed to ensure that user input is validated against a defined schema, okay, due to like uh, non security of the data, okay, which is in the IoT. The hacker can hack in this layer. Okay, here transport layer, vulnerable ports, okay, like different ports whatever you have used, okay, you can you may have the what you call, you may have the chances of hacking. The network layer is packet sniffing and DOS attacks such as ping floods and ICMP attacks. For data adaptation, unencrypted data store, tempering or sniffing. These are the possible things. It is not that every time, every this thing, anyone, okay, can. Just I am repeating, it can. We are just telling you the possible things. Then physical data link layer, insecure in protocols, okay, DHCP or STP, LAN node attack using MAC flooding or ARP poisoning, physical or service disruptions. Okay, so in physical and data link layer, we get the threats, okay, as if you see categorize more. Then layer one attack solutions, okay, how to mitigate that depends on the devices used, okay, link level provisioning of security, okay. It you I mean use Bluetooth LE link, it levels AES CCM 128 authenticated encryption algorithm for confidentiality and authentication. Okay, so this is actually how you can find the solution, okay, for the layer one. Okay, if you're using Bluetooth, these are the things. Just actually if you remember 128 authenticated and encryption bits are used, then that is sufficient. If you remember these names, that is also fine. Then if you're using Zigbee at link level, then security using AES ECM, again 128 bits. Layer 2, if you go, then it is programming the network switches to prevent internal node attacks during use of DHCP or spanning tree protocol. Okay, so there actually we discussed about ports, right? So additional controls can be ARP inspection, then disabling unused ports, okay, then enforcing effective security of virtual LAN to prevent VLAN hopping, because now it is most of the cases it is virtual network, right? So in that cases, effective security in while hopping, that also can be introduced to minimize the attacks. Then in layer 3, it uses use of temper resistant, okay, router in this. Actually, whatever, let me tell you, router are there to route this route the data to a different directions. That can be done at the physical or data link layer. Okay, so that here it is like it need not be the datas or the security key, okay, security code need not be opened in this layer. Okay, use of packet filtering, a firewall for controlling routing messages and packets data between layer 3 and layer 4 for reducing the risk. Then in layer 4, okay, it is a port scanning method to identify the vulnerable port, effective firewall configuring, okay, as you go to the higher levels, it is firewall configuring only comes to minimize the attacks, and opening of network ports and locking down ports only to those required. Okay, so this is again an algorithm, okay, when to give the network ports, okay, when to lock it down. It is the algorithm. In that again, your security or whatever you call your encryption plays a high role over here. Okay, DTLS between layers 5 and 4. It has three types of security services: integrity, authentication, and confidentiality. Inclusion of simple authentication and security layer for security when using the XMPP protocol. Okay, so this is again a separate layer is introduced for the exclusively for the security purpose. Now last one is application, that is 5 and 6 layers. Results of poor coding practices of application programmer. Okay, that is the this thing. So you need to go for a higher quality of use HTTPS secured link. Okay, for web applications. Okay, it has content privacy domain header. This actually we have studied, allows use of digital signatures and encryption. Okay, various encryption options. Okay, it has HTTPS, that is the features. Okay, then server client negotiations. In a sense, actually, you can include uh, some more security, what do you call security threats. Okay, to go for to authenticate. Okay, now usually we get some again something security codes when we try to enter some security check will be there. You might have observed different type of security checks will be there. Okay, identify some object, identify the objects, so something like that. Okay, so that depends on again system to system what level of security is required. Okay, so high security you can think of your OTPs. Okay, direct specification is done here. One way or two-way security is possible. Okay, now here CISO suggested layered framework solutions are okay. Role based, one to 6 is role based security. Okay, then 1 to 4 is anti temper and detection based security. 1 to 6 is data protection and confidentiality, and IP protection is also okay. So uh, these are the security measures which we have to take. Okay, so it is in different like what you call programmers or different platforms, different security measures are taken. Okay, so a few are standardized, still it is going on. Again, if you take IBM or Cisco, they have different. Okay, AT&T, they have different. Initially only they had designed for their network. Okay, then international standard has come, which is as now it is like in the basic level, but it is secured. Okay, most of the security aspects are covered in that. And again, any security is required, that depends on the that particular companies or particular application. Okay, depending on the application you can have the security and privacy uses. Okay, so this was the security. Okay, about the security and this thing. Now okay, some examples for the of security issues for which use case we studied about the use case and misuse case, right? So use cases are required. Okay, now boot process protection. Now boot process is running the initial programs. Okay, if it is corrupted, then the system fails. So there actually we need to have use cases. Then secure software and firmware update. When software and firmware update, secure updates are needed. Okay, so their security, that is the use case, comes into picture. Next, stored data encryption and integrity protection. Okay, so data which is stored, okay, it has to be encrypted. So again, how the encryption is done? So generate the random number, generate the key, then encrypt, then send the key. Correct, no? So this is actually one of the misuse. Sorry, use case, not misuse. Use case. Misuse case, actually how to prevent it. Okay. Next, platform integrity verification. The device platform integrity needs verification. Okay, so there are chances that fake device platform is able, okay, it is hacked, your thread is hacked and you are able to communicate with the fake device platform. So to overcome that problem, device platform integrity needs the verification. So again, you run the use case. Key generation, okay, management and exchange of security, what you call, security parameters. Okay, so that should for the authentication authorization purpose. Okay. So we have one predefined use case. So similarly, we have for some other applications also use case. Now if you're going for misuse, this thing examples. Okay, so misuse cases depicts uh, the requirement. Actually, it has to find out the fake server. Okay, misuse case have to find out the fake server. Okay, fake device platform, flooding of TCP. Okay, unauthorized access to a data store. So all these are actually the jobs or the functions of the misuse cases. Okay, the window will alert that the unauthorized access to a data store has come. That is like uh, indication or notification. Okay, then actually the user can decide whether it is unauthorized or like how is it, or like fake server, was dropping. Okay, all these things. Then audit and accountability is also one of the example of misuse cases. So this was actually the different type of use cases and misuse cases. So this completes privacy, security, and trust. Okay, now we'll go back. Okay, now any doubt? Yeah, actually, yesterday I did not put the video recording, so today I will be putting that. This class also I will upload. After this, actually, I will record and I will upload it. Okay, so please go through that. Yeah, now it is time for any doubts if you have. Any doubts? No? Okay, fine. Okay, now everyone, yeah, attendance will is there, but all of you just type this, okay, because sometimes in the attendance it doesn't come. Yeah, I will see the your chat box, then I will put the attendance. So, okay, type something and you can leave the meeting.